All right, working out 11.1 problems here. Gonna roll right along. Feel free to pause if I go too fast. Gonna graph this first. Could use a calculator. Looks like it starts at the point 1, 2, goes up to 3, 4. That's it. So definitely a function. And x equals root t minus 2, x squared equals t minus 2, t equals x squared plus 2. Therefore, y equals x squared plus 2 plus 5 over 4. Y equals x squared over 4 plus 7 over 4. Like I said, I'm rolling fast, so pause if I lost you. Gonna graph this one. Looks like it starts at 0, 2. That's obviously starting point, ending point, same thing above, starting point, ending point. And looks like it hits here at 1, 0 and hits here at 0, -2. Y is not a function. Vertical line test and all that, even though each one of these pieces is a function. So let's start squaring things. X squared equals sine squared t. Y squared over 4, so we move the 2 over, equals cosine squared. Add them, we get x squared plus y squared over 4 equals 1. Sine squared plus cosine squared is 1. Definitely want to be as lazy as humanly possible. Now they do ask me to find an equation that relates x and y. If we wanted to keep going, we could. We could solve this for y. We would get y equals plus or minus 2 square root of 1 minus x squared. But didn't really have to do that. This is weird. Plug in 0, x equals 0. Plug in 0, cosine equals 1. I get it, from 0 to 2 pi. So we've got two curves going on here. One does that. And then when the cosine gets in the negative world, it does that. Which is making my brain hurt, so I don't even want to try and describe it. All I know is y is definitely a function of x. Y equals cosine of 2t looks like I'm going to do some fancy math to this. Give me a moment and figure out what the heck is going on here. Yeah, I guess I can use a trig identity and say that this is 2 sine squared t. Sure, whatever. We know that x equals sine of t and x squared equals sine squared t. Now I could sub in y equals 1 minus 2 times x squared. also known as negative 2x squared plus 1. So we've got a upside down parabola, which is what we graphed. Wow, I would never have been able to figure that out without my notes, so hopefully that doesn't bother you too much. One bizarre one to go, which is what makes parametric so very much fun. Starts here, goes here, goes here. Something like that. Probably want to use a calculator to graph that one. Y is not a function of x. And x equals sine 6t. Over here, t equals y over 2. Therefore, x equals sine of 3y. I'm done. But get that whole 3y equals arc sine of x, y equals arc sine of x all over 3. Could do that one too. Sorry about that. All right. Now we got domain restrictions in here, so that would not really be the same. I would definitely stop there. But we're not going to worry about that because we're lazy. Onwards. For no particular reason, I'm going to do dy dt first. And that equals negative root 3 sine of t. Dx dt equals negative sine of t. Dy dx equals, signs cancel out, negatives cancel out, root 3 dy prime dt. Remember, that's the derivative of this with respect to t is 0. Therefore, d squared y over dt squared is 0 over negative sine of t is 0. Dy dt equals 1 over t. Dx dt equals negative 1 over t squared, because this is 1 t to the negative first, negative, negative, yep. Dy dx equals 1 over t over negative 1 over t squared, negative t, 1 over t over negative 1 over t squared. Flip and multiply, negative t. Dy prime dt equals negative 1. So therefore, d squared y dx squared is negative 1 over negative 1 over t squared, which is t squared. At this point, you might be like, what is going on? How can a derivative of that and a second derivative? Yeah, it's parametric. I warned you. It's crazy. All right, onwards. Dy dt equals 2t minus 1. There's really not enough room on this one, so be economical. Dx dt is 2t plus 1. Dy dx is 2t minus 1 over 2t plus 1. No, there's nothing we can do with that. Mildly annoying. Dy prime dt is 2t plus 1 times 2 minus 2t minus 1 times 2 over 2t plus 1 squared. This is 2 of that. This is 2 of that. The 4t and negative 4t are going to cancel out. We're left with 4. So that equals 4 over 2t plus 1 squared. Therefore, d squared y dx squared is 4 over 2t plus 1 squared over 2t plus 1. Which is 4 over 2t plus 1 to the third. Yeah. These next three problems are similar in that there's just a lot of math going on. dy dt equals -2 sine of 2t. dx dt equals -2 cosine of t. dy dx equals, negatives cancel, 2's cancel, sine of 2t over sine of t. We can do some fancy math here. Sine of 2t is the same as sine of t cosine of t with the 2 out front. Divided by sine of t gives us 2 cosine of t, which makes life a lot easier. dy prime dt is -2 sine of t. d squared y dx squared equals -2 sine of t over -2 sine of t, which is 1, which is crazy and bizarre. dy dt equals, oh boy, this ought to be fun, 4 ln of I gotta think for a minute. Yeah, this will work. 4 ln of 3t times 1 over 3t times 3. 4, what's the derivative inside? 1 over 3t times 3. By something's bothering me to the third. I don't like this. Something's wrong. Yeah, I've made a mistake somewhere near and I can't see where it is. I'm going to cross this out. We're going to start with y equals ln of 3t to the fourth, which is equivalent of 4 ln of 3t. So that dy dt is 4 times 1 over 3t times 3. 4 over t. I'm forgetting something up here, a rule of what I'm doing, so that's upsetting to me, but it'll come to me in the middle of my sleep tonight. dx dt equals 1 over 2t times 2 is 1 over t. dy dx 4 over t or 1 over t 4. Since dy prime dt is 0, d squared y over dx squared is 0. Boy, that's going to bother me for a long time. That's fine. Over here, dy dt equals 5e to the 5t. dx dt equals 5 over 5t, 1 over t. Boy, this is bothering me. Okay, dy dx equals 5e to the 5t over 1 over t is 5t e to the 5t. D squared y dt is the derivative of this with respect to t. Leave it, derivative, derivative, leave it. Factor out 5e to the 5t leaves me with 5t plus 1. Just a little bit neater looking, not much. D squared y dx squared is 5e to the 5t over 5t plus 1 over 1 over t, which equals 5t e to the 5t, 5t plus 1. Wow. That's what I call working for a living. Good thing I got paid to be here. Wait, do I get paid to be here? Can never be sure. All right, here we go again. Graph these suckers. This would be nice to know what they look like. I think they go something like this. Starting point. Graph them on a calculator, graph them however you want. Doesn't really matter. Come back and find the lowest point. We need the derivative. dy dt equals t minus 2. I'm going to need to set the top equal to 0. I don't care about the bottom. I only care I don't blow it on the bottom. T minus 2 equals 0. T equals 1. dx dt, again, we're just checking to make sure things don't go wrong. 2t plus 2. Plug in 1, I don't get 0, that's fine. Therefore, when dy dx equals 0, t equals 1. All right, so the point that t equals 1, yeah, this doesn't mean anything. There's no t on this. It's about here. That's where t equals 1. But what's that point? Well, that point is x equals 1 plus 2 equals 3, and y equals 1 minus 2 plus 3 equals 2. Therefore, the lowest point is at 3, 2. Really should do the whole derivative thing, high, low point. Okay, yeah, it's a low point, low, high point, whatever. But looking at the graph, it's pretty clear. Graphing this by hand with a calculator or whatever. Looks like it does something like this to this point. All right, off we go again. dy dt equals 2 secant tangent theta t. All right. That equals 2 sine of t over cosine squared t. Only care when top is 0, top of the top. That's when t equals 0. Let's make sure we don't have a problem there. Dx dt is secant squared t, which is 1 over cosine squared t. Plug in 0, that's 1, 1 over 1, we're okay. Therefore, t equals 0. Oh, that's right, that's what it looks like. No, it doesn't mean anything. That's got to be where x equals 0. Tangent of 0, 0. Oh, yeah, okay, it did work. X equals tangent of 0, which is 0. Y equals 2 secant of 0, which is 2 over cosine of 0. which is 2. 0, 2. Right there. All right. I think I'm doing these wrong. So, identify the point. Justify you found it by Calc. Yeah, I'm just doing it straight with the calculus. So, yeah, they say the graphs is the calculator. If you don't know how, go Google it. It's pretty straightforward. This one looks like it does something like this. So I'm guessing 0, 1. Off we go. dy dt equals -2 sine of 2t. Where does that equal 0? Sine equals 0 when t equals 0. Let's check dx dt. 2 cosine t. We're okay. Plug in 0, we don't get 0. So I'm not dividing by 0. X equals 2 sine of 0, 0. Y equals cosine of 2 times 0 equals 1, 0, 1. Graph this one. Up we go. I don't see no min, no max, so I don't think we're going to have one. We're going to have to do it at the 0 or the 10. Let's know what's going on here. dy dt, they want the rightmost point. That's funny. dy dt equals, oh, this nonsense again. One over 4t squared times 8t, which is 2 over t. T cannot equal 0. So there's no max or min. Yeah, that's what we see. Do I need to do a dx dt? No, I don't really care. There's nothing to check. Rightmost point, assuming it's going up to the right, which it is at t equals 10. So x equals ln of 5 times 10 equals ln of 50. Sure, whatever you say. Y equals ln of 4 times 10 squared equals ln of 400. So the rightmost point is ln of 50, ln of 400. I don't know about you, but I find that incredibly unsatisfying. Oh well. All right. One more crazy page. Find the point. Tangent line, the curve is horizontal or vertical, meaning if the top sets to 0, we're there. If the bottom sets to 0, we're also there. So let's try it first. dy dt equals secant squared t. That's 1 over cosine squared. It's not possible. So there is no horizontal tangent. Dx dt secant tangent, which is sine of t over cosine, square root of t. Don't care, I just care about the top. So that happens when t equals 0. So at t equals 0, x equals 1. Ooh, I gotta slow down. T equals 0. Right, t equals 1. X equals 1. At t equals pi, I gotta go look at our interval. Oh, they don't give us one. At t equals pi, x also equals 1. So at t equals 0, comma pi, comma dot dot dot, y equals 0. So the points are -1, 0, and 1, 0. I happen to know this is an ellipse. No, it's a hyperbola. So yeah, graph it if you need to, but that's where your vertical lines are going to be. That's pretty cool. dy dt equals 3 cosine of t. 3 cosine of t is 0 when t equals pi over 2 plus k, where k is all integers. Oops, forgot a pi in here. K times pi, I should say. So it ends up pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, so on and so on. So have your horizontal tangent x equals, plug in pi over 2, 1, negative 2 plus 3. No, it's 0, negative 2. And y equals, and it's always going to be negative 2. Y would equal either positive 1 or negative 1. So if it was positive 1, you'd get 4. When it's negative 1, you'd get negative 2. It'd be negative 1 times 3, negative 2. Yeah, negative 2. So let's check out the bottom. Dx dt equals negative 3 sine of t. That equals 0 when t is pi k, where k is all integers. So for your vertical, here's your horizontal. In other words, negative 2 comma 4, negative 2 comma negative 2. So for your vertical, let's see what happens. Plug in pi, and we get negative 1. Plug in 2 pi, we get 1. So we would have, I'm doing this right, 1 or negative 5. X equals 1 or negative 5. And y is always the same because it's always 0. So we just get 1. Good. So the points are at 1 comma 1 and negative 5 comma 1. That's crazy. All right, video is way too long. You get the general idea. Oh no, it's not. I take it back. Oh, we have to do that again. And those problems are getting a little bit over the top, so my bad. Dx dt is 3 cosine of t. Dy dt is negative 3 sine of t. Length equals integral 0 to pi square root 9 cosine squared t plus 9 sine squared t dt, which 9 factors out becomes 3. Left with sine squared plus cosine squared is 1. Integral 0 to pi of dt, which is 3t 0 to pi. We get 3 pi. I'm sorry, that's really cool. This one gets obviously uglier. Dx dt is -6 cosine squared t times sine of t. dy dt is 6 sine squared t cosine of t. Length is integral. By the way, I felt like putting a pi out front after unit 8, so yeah, don't make that mistake. 36 cosine to the 4th t sine squared t plus 36 sine to the 4th t cosine squared t dt. All right, pull it all out. I can pull out, put the 6 out front. Cosine squared and sine squared come out. After I square root them, I just get sine of t cosine of t, and I'm left with the sine squared of sine squared plus cosine squared plus sine squared t dt 1. Integrate that, and we get 6 sine squared t over 2. We are actually going to change this, because if I graph it, I know there's symmetry. I'm going to leave the 6 there. We're going to say there's 4 of them. We're going to do it from 0 to pi over 2. Because if you graph it, you'll see there's symmetry, like the example we did in class. Sine of pi over 2 is 1, 1/2, 3, and 4 is 12. Wow. Don't be shy about using a calculator for that one either. Dx dt equals 3/2 8t plus 8. 8, and there's still a 12 there. Goodness gracious. A lot of this cancels. 4, 3. Oh, look at that. To the 1/2. 4 is a cancel. 3 has 1/2. My bad. And dy dt equals 2t plus 1. Length equals integral 0 to 2. I'm going to square this right away, so it's 8t plus 8. Plus, I'm going to square this. 4t squared plus 4t plus 1 dt equals integral 0 to 2. 4t squared plus 12t plus 9 dt, which I believe is 2t plus 3. Yep, squared. So this is the square root of 2t plus 3 squared, 2t plus 3. It really feels like cheating to me, but what are you going to do? Is t squared over 2 cancel plus 3t, 0 to 2, equals 4 plus 6, 10. That's crazy. All right, this has been fun. Dx dt equals, holy cow, secant t plus times tangent t plus secant squared t all over secant t tangent of t. If you're not sure where you got that, that's okay, neither am I. Let's see if I can figure it out. Ln of secant t plus tangent of t Yeah, I did some fancy math and some simplifying. Minus derivative of that is cosine of t. Wow, it's the first time I've ever done dx dt first. Dy dt is negative sine t. So I'm shortcutting. I'm just going to cut to the chase. L equals integral from 0 to pi over 3 square root secant of t minus cosine t squared plus sine squared t. Yes, that's right. This all reduces. Brutal, huh? Well, the secant's clearly crossed out, tangent crossed out here. I can flip it up there, I get minus cosine, yada, yada, yada. Yeah, I forgot to write all this out. Yeah, and then it cancels that. Yeah, this is a, yeah. This is equal to that. Don't forget to square it. Equals 0 pi over 3 square root. Distribute this one out. Secant squared t minus 2 cosine of t over cosine of t. Plus, that's cosine squared, sine squared, 1. Which you get secant squared minus 1, which is tangent squared, which is the square root is tangent of t. Notice we haven't done any calculus yet. dt, dt, which integrals ln of cosine of t, 0 to pi over 3, which is ln of 1 minus ln of 2, which is negative ln of 2. Because ln of 1 is 0, which is ln of 1/2, I believe. Crazy times, huh? Wow. All right. Good luck.